So, I'll be discussing about graphing exponential function. So first, let's have a given. F of x is equals to 1 half raised to x plus 2, and f of x equals to 1 half raised to x minus 2. So first, let's make a chart for x and y axis. So the domain will always be given. So for example, I will use 0, 1, and 2. So we need to substitute the value of x to our function to get the value of y. So if you substitute 0, we will get 1. If you substitute 1, we will get 1 half. If you substitute 2, you will get 1/4. So let's graph. X and y. So 0 and 1. 1 and 1 half. 2 and 1/4. So the line will be like this. So we will set another domain and range for us to determine if the graph is vertical translation or horizontal translation. So, as we did a while ago, we will just substitute the value of x to our function. So, if you substitute 0 to this function, we will get 3. If you substitute 1, you will get 2.5. If you substitute 2, you will get 2.25. So, let's graph 0 and 3. 0, 3. 1 and 2.5. 2 and 2.25. So the graph will be like this. So the next, if you substitute 0 to this function, you will get -1. If you substitute 1 to this function, we will get -1.5. If we substitute 2 to this function, we will get -1.75. So let's graph 0 and -1. 1 and -1.5. 2 and -1.75. So the graph will be like this. So the graph will be vertical translation because as we can see, the line is going upward. So I'll be discussing about graphing horizontal translation. So let's have a given first. F of x is equals to 1 half raised to x plus 2, and f of x is equals to 1 half raised to x minus 2. So the first step is we will make a chart for x and y axis. So we will always use for the domain is 0, 1, and 2. So substitute the value of x to our function to get the value of y. So if you substitute 0, we will get 1. If you substitute 1, we will get 0.5. If you substitute 2, we will get 0.25. So this is the original graph. So let's graph. So 0 and 1. 1 and 0.5. 2 and 0.25. So here, so the line will be like this. Like that. So we will set another domain and range for us to determine if the graph is horizontal translation. So as we did a while ago, we will just substitute the value of x to the function. So if we substitute 0 to this function, we will get 4. If you substitute 1, we will get 2. If you substitute 2, we will get 1. So let's graph. 0 and 4. 1 and 2. 2 and 1. So the line will be like this. So let's make the another function. So if you substitute 0 to this function, we will get 0.25. If you substitute 1, we will get 0.13. If you substitute 2, we will get 0.06. So let's graph 0 and 0.25. 1 and 0.13. 2 and 0.06. So the line will be like this. So this is an example of horizontal translation. So I'll be discussing about graphing, vertical stretching, and shrinking. So let's have a given first. F of x is equals to 2 times 1/2 raised to x, and f of x equals to 1/2 times 1/2 raised to x. So the first step is we always make a chart for x and y axis. So x and y. So the domain will always be 0, 1, and 2. So we will substitute the value of x to our function. The original function is 1/2 raised to x. So we will just substitute 0 to 1/2 raised to x. So if you substitute 0, we will get 1, and if you substitute 1, we will get 0.5, and if you substitute 2, we will get 0.25. So let's graph. So 0 and 1. 1 and 0.5. 2 and 0.25. So the line will be like this. So we need to set a new domain and range for us to determine if the graph is vertical, stretching, and shrinking. In this case, we will use 2 times 1/2 raised to x. So we need, as we did a while ago, we will just substitute the value of x to this function. And if you substitute 0 to this function, we will get 2. And if you substitute 1 to this function, we will get 1. And if you substitute 2 to this function, we will get 0.5. So let's graph 0 and 2. 1 and 1. 2 and 0.5. So the line will be like this. So next we will make the last function. So next we will use the 1/2 times 1/2 raised to x. As we did a while ago, we will always just substitute the value of x to this function. So if you substitute 0, we will get 0.5. And if you substitute 1 to this function, we will get 0.25. And if you substitute 2 to this function, we will get 0.125. So let's graph 0 and 0.5, 1 and 0.25, 2 and 0.125 or 0.13. So the line will be like this. This is an example of vertical stretching, because as you can see, the line is going upward, while the other one is vertical shrinking. So I will be discussing about graphing horizontal stretching and shrinking. So let's have a given first. F of x is equals to 1/2 raised to x times 2, and f of x is equals to 1/2 raised to x times 1/2. So first step is to make a chart for x and y axis. So x and y. So we will always use 0, 1, 2 in the domain. So as an example, we'll use 0, 1, and 2. So the original function is 1/2 raised to x. So we will substitute the value of x to 1/2 raised to x. So if we substitute 0, we will get 1. If you substitute 1, we will get 0.5. If you substitute 2, we will get 0.25. So let's graph. So 0 and 1, 1 and 0.5, 2 and 0.25. So the line will be like this. So we will make a new domain and range. So we will use 1/2 raised to x times 2. So as we did a while ago, we will just substitute the value of x to this function. So if you substitute 0 to this function, we will get 1. if you substitute 1 to this function, we will get 0.25. If you substitute 2 to this function, we will get 0.06. So let's graph 0 and 1. 1 and 0.25. 2 and 0.6. So the line will be like this. So we will make the next function. We will just use this function. So 1/2 raised to x times 1/2. So if you substitute 1 to this function, we will get 1. If you substitute this value to this function, we will get 0.71. If you substitute 2 to this function, we will get 0.5. So substitute. So let's graph 0 and 1. 1 and 0.71. 2 and 0.5. So the line will be like this. And this is an example of horizontal stretching and shrinking.
We will be discussing about rational function. I will give an example of its f minus 4 over 2x minus 9. There are six steps for rational function. First, we have to find the vertical asymptote. The second one is to find the horizontal asymptote. The third one is find the y-intercept. Fourth, find the x-intercept. 5, make a t-chart. And 6, graph asymptotes. In y-intercept, we're gonna set x to 0. So 0 minus 4 over 2 over 0 minus 4. Over 9, I mean. So that will be negative 4 over negative 9, or just simply 4 over 9. So this will be our y-intercept. And in the x-intercept, in x-intercept, we just have to set the numerator to 0. So x minus 4 equals to 0. After that, we will transpose negative 4 to the right side. So it will be x equals to positive 4. It became positive 4 because we transpose it from left to right. So it will be positive 4.
Go.
In vertical asymptote, we're gonna use the denominator. So 2x minus 9, and we have to set it to 0 equals 0. After that, 9 to the right side, so it will become 2x equals 9. After that, we're gonna divide it both sides by 2, so divided by 2. So we will cancel this, cancel out. So x equals to 9 over 2. That will be our vertical asymptote, or simply 4.5. In horizontal asymptote, we're just gonna get the leading coefficient of the numerator and the denominator. So it'll be simply 1 out of 2, because x minus 4 over 2x minus 9. This will be 1, this will be 2, so pak ganun. In the t-chart, we're just gonna substitute the x to the given. So 0 minus 4 over 2, 0 minus 9 is equal to 0.44. 0.44. We're gonna do that to all the x here, and we're gonna substitute all the x in the given. So into 0.4, and in 4 it'll be just 0, and 6 0.67, and 8 0.57. We're gonna graph this t-chart into in a Cartesian plate. So we're gonna graph this. Vertical asymptote will be at 4.5, so 1 2 3 4.5, it'll be here. We'll graph it at broken line so we will not be confused. And in the horizontal asymptote, it'll be 0.5, so it'll be here. This will be the horizontal asymptote, and this will be the vertical asymptote. So after that, we're gonna graph the t-chart, so 0.4, 0 and 0.44, 2 and 0.4, 4 and 0, 6 and 0.67, and 8 and 0.52. After that, we're gonna, it should not touch the asymptote. It'll be like this, and the other one will be like this. So this is the rational function. That's it. Thank you.
So I will be discussing about the logarithm functions. So first, let's have a given. Log 5 125. This logarithm function is read as log base 5 of 125. And let's solve for x. In order to get the x, we have to convert it into a fraction form. So the numerator will be the highest number in your logarithm function. And your denominator will be the base. In order to get the x, we have to think first what will be the exponent of 5 in order to get the 125. So the x will be 3. If you are going to check that, 5 raised to 3 is equal to 125, because 5 times 5 is equal to 25, and times 5 is equal to 125. So the value of x is equal to 3, because the 5 raised to 3 is equal to 125. Meaning to say, 3 is a correct answer. This is another way in solving logarithm function. So first, let's have a given. Log base 3 of 1 over 9 is equal to x. So if your c is a fraction, you have to convert it into a whole number. So how will we going to convert it? You have to reciprocate it first, because we need to have a same basis. Your first base is 3, so we need to get a same as 3. So 3, 1 over 9. You have to reciprocate it first. So that will be 9. Still, your base is not the same. So you have to convert it into an exponential form. So what is the exponential form of 9? Definitely 3 raised to 2. And your exponent should be a negative number. Why? Because you reciprocate it. it. So as you get the 3 raised to negative 2, you get the correct answer. So x is equal to negative 2. And that is the correct answer.
Hi, I will teach you how to solve rational inequalities. First, let's have a given. 2x plus 4 x minus 7 is greater than 0. First, let's solve for the numerator. 2x plus 4 is equals to 0. Let's transpose plus 4 to the right side. So, if we transpose, plus 4 will be going negative 4. So, negative 2x 2 equals negative 4 minus 2. So, the answer will be x is equals to negative 2. And the denominator, let's compute for denominator. X minus 7 is equals to 0. Let's transpose. X will be equivalent to 7. The next step, to prove that the number is correct, we must use number line to determine if positive or greater than 0. So this is how to use number line. So negative 2 and 7. First, let's have a number that is lower than negative 2. So we must use negative 3 or anything. Let's find the number between negative 2 and positive 7. For easy, we must use 0. And for the last number, we must use a number that is greater than 7. We can use 8, 9, 10 or something. So now I will use 8. To prove this is right, let's switch the like this. 2 negative 3 plus 4 negative 3 minus 7 is greater than 0. 2 negative 3 is equals to negative 6 plus 4 and negative 10. And negative 6 plus 4 is equals to negative 2 negative 10. So this is right. Negative 2 is right. So let's check this. 1 0 2 0 plus 4 0 minus 7 is greater than 0. Let's solve this. Negative 4 over 7. I think it's not. So let's x this. Plus is 8. So 2 8 plus 4 over 8 minus 7. So the answer will be 20 over 1. So 20 is greater than 0. So let's check this. So the final solution is x 2 or x greater than 7 or negative infinity, negative 2 or 7 to positive infinity. That's all.
Today we're going to discuss about finding the inverse function of a one-to-one function. So first, what is the inverse function? Inverse function is the reverse of a one-to-one function. So what are the steps in finding the inverse function? First step is to write the equation in the form of y is equal to f of x. Step 2, interchange x and y. Step 3, solve for y. Step 4, write f raised to negative 1 for y. So first, let's use f of x is equals to x raised to 3 as a given. So first, let's apply the first step. Write the equation in the form of y is equal to f of x. Then, interchange x and y. Step 3. Solve for y. So that's how we solve it. We're going to cube both sides so that we can get the value of y. So we'll have 3 cube of 5. Then last step, write f minus 1 for y. We can use any domain. So as an example, I'll use -2, -1, 0, 1, and +2. For the y, we should substitute the value of x in order to get the value of y. So substitute the -2 to x raised to 3. So that will be 2 raised to 3. And the outcome will be 8, -8. For the -1, we'll substitute that to x. That will be -1 raised to 3, and it will come up with -1. So the 0 will get 0, and we're just going to copy, but you know, it's positive. So let's graph the chart. So let's plot the chart. So in the x we have -2, and in the y we have -8. So here's the -2 and here's the -8. -1 and -1. So we have it here. 0 and 0. Have that. +1 and +1. +2 and +8. So here. So you should connect it. That is the original graph. So for us to get the inverse function, we should interchange the values of x and y. So we're going like this. So we'll put -8, -1, 0, +1, and 8. So for the values of y, you should put the values of x, -2, -1, 0, +1, and +2. So let's plot the points. So for the x, we're going to put it here, the negative. So let's plot the chart for inverse function. So we have, for the x, we have -8, and for the y, we have -2. So we're going to plot it here. we have -1 for the x and -1 for y. So plot it here. We have 0 and 0 for both. And we have 1 and 1 for both. And we have, for the x, we have +8, and for the y, we have +2. So here. So let's trace the dots in order for us to get the figure. So that's how you get an inverse function.
Hello guys, today I'm gonna teach you how to graph logarithmic functions. So first, let's have a given. Log base 2 of x is equals to y. So first, you need it to convert into exponential form. So 2 with the x equals to 1. Then you need to make a t chart. To make a t chart of this one. So I set the values of 0, 1, and 2. Then you just need to substitute values. So 0, 1, 1 and 2, and then 2 and 4. Then you need it. Then next is log base 2 of x is equal to 1. Then same procedure, you need to set the values. So we studied that they are inverse to each other, so just interchange the values 1, 2 and 4. Then 0, 1 and 2. Then let's make a graph.
Start from scratch.
So a partition thing. First, you need to graph the exponential form. 0, 1, 1, 2, then 2 and 4. Then you need to graph the log form. 1 and 0, 2 and 1, and 4 and 2. As you can see, the graphs are mirrored to each other. As you can see, they are mirrored to each other, and therefore you just need to graph it. And for me, it was an easy thing to do. So that's all.